Underwriters Laboratories, or UL, uses the same testing procedures for grounding washers as they do for connectors. These procedures are designed to ensure that the washers provide a reliable electrical connection between equipment and the grounding system. While the specific test methods used by UL for grounding washers are not publicly available, it is likely that they include several key tests. Firstly, there is continuity testing. This test confirms that the washer provides a low-resistance electrical path between the equipment and the grounding system. Low resistance is crucial for effectively carrying fault currents to ground, allowing overcurrent protection devices like circuit breakers to operate and clear the fault. Secondly, there is pull-out testing. This test measures the force required to pull the washer out of place. The washer must withstand a certain amount of force to ensure it remains securely in place, maintaining the electrical connection even under stress or vibration. Thirdly, corrosion testing is performed. This test exposes the washer to corrosive elements to ensure that it will not deteriorate over time. Grounding connections need to remain effective throughout the lifespan of the electrical system, and corrosion can significantly degrade their performance. UL does not specify specific current values for grounding washers. However, they do require that the washers meet the minimum conductivity requirements specified in the National Electrical Code, or NEC. The NEC provides guidelines for grounding and bonding to ensure electrical safety. Grounding washers must meet these conductivity standards to effectively carry fault current. It is important to note that UL requires that paint be removed from painted surfaces before installing grounding washers. Paint can act as an insulator, preventing the washer from making proper contact with the metal surface. A proper metal-to-metal connection is necessary for effective grounding. Grounding washers are an important part of the electrical grounding system. They help to ensure that equipment is properly grounded and protected from electrical hazards. By using grounding washers that meet UL testing requirements, you can be confident that you are providing a safe and reliable electrical connection. Electrical grounding is a critical safety measure in electrical systems. Its primary purpose is to provide a low-impedance path for fault currents to return to the source, which allows overcurrent protection devices like circuit breakers and fuses to quickly interrupt the circuit and prevent electrical shock hazards and equipment damage. Grounding also helps to stabilize voltage levels and reduce electrical noise in sensitive electronic equipment. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, which is connected to the earth. This grounding electrode provides a reference point for the electrical system's voltage. Equipment grounding conductors, or EGs, are used to connect the metal enclosures of electrical equipment to the grounding system. These conductors provide a path for fault currents to flow back to the source. Bonding is another important aspect of electrical grounding. Bonding involves connecting together all metal parts of an electrical system, such as metal conduits, enclosures, and equipment frames, to create a low-impedance path for fault currents. This helps to minimize voltage differences between different parts of the system and reduce the risk of electrical shock. Grounding washers play a crucial role in ensuring the effectiveness of the grounding system. They provide a reliable electrical connection between the equipment and the grounding conductor, even in situations where the surfaces are uneven or corroded. Grounding washers are typically made of materials with high conductivity, such as copper or aluminum, and are designed to provide a large contact area for the electrical connection. When selecting grounding washers, it is important to choose washers that are listed by a recognized testing laboratory, such as UL. This ensures that the washers have been tested and meet the applicable safety standards. It is also important to choose washers that are compatible with the materials being connected. For example, when connecting aluminum equipment to a copper grounding conductor, it is important to use bimetallic washers to prevent corrosion. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are based on the principles of electrical safety and are designed to minimize the risk of electrical shock and fire. The NEC covers various aspects of grounding, including the size and type of grounding conductors, the installation of grounding electrodes, and the bonding of metal parts. It is important to follow the NEC requirements when installing and maintaining electrical grounding systems. Regular inspection and testing of grounding systems are also important to ensure their continued effectiveness. Grounding connections can corrode over time, and grounding conductors can become damaged or disconnected. Regular inspection can help identify and correct these problems before they lead to electrical hazards. Testing grounding systems involves measuring the impedance of the grounding path to ensure that it is low enough to effectively carry fault currents. There are various methods for testing grounding systems, including the fall of potential method and the clamp-on ground resistance meter method. Proper grounding is essential for electrical safety. It protects people from electrical shock, prevents equipment damage, and reduces the risk of fire. By following the NEC requirements and using properly selected and installed grounding components, you can ensure that your electrical system is properly grounded and safe. Regarding the removal of paint before installing grounding washers, it's crucial because paint is an insulator. Electrical current follows the path of least resistance, and paint significantly increases resistance. Even a thin layer of paint can impede the flow of electricity, preventing the grounding washer from establishing a solid electrical connection. Therefore, removing paint ensures a direct metal-to-metal contact, which is necessary for a reliable grounding path. The process of paint removal should be done carefully to avoid damaging the underlying metal surface. Wire brushes, sandpaper, or chemical paint strippers can be used. After removing the paint, it's often recommended to apply a corrosion inhibitor to the exposed metal to prevent rust and maintain the integrity of the grounding connection over time. The use of star washers or other types of locking washers in conjunction with grounding washers can further enhance the connection. These washers have teeth or ridges that bite into the metal surface, providing additional mechanical and electrical contact. They also help to prevent the connection from loosening due to vibration or thermal expansion and contraction. In addition to grounding washers, other types of grounding connectors are available for different applications. These include grounding lugs, which are used to terminate grounding conductors to equipment or enclosures, and grounding clamps, which are used to connect grounding conductors to pipes or other metal structures. The selection of the appropriate grounding connector depends on the specific application and the type of materials being connected. When working with electrical grounding systems, it is important to follow all applicable safety procedures. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing the circuit before working on any electrical components. It is also important to be familiar with the NEC requirements for grounding and bonding and to follow these requirements carefully. Improper grounding can create serious electrical hazards, so it is essential to take the necessary precautions to ensure safety. In summary, grounding washers are vital components of electrical grounding systems, ensuring a reliable connection between equipment and the grounding conductor. UL testing procedures validate their performance, and proper installation practices, including paint removal, are critical for their effectiveness. Always adhere to NEC guidelines and safety procedures when working with electrical grounding systems to protect against electrical hazards. Remember, a well-grounded electrical system is a safe electrical system. Electrical grounding and bonding are essential safety measures to protect people, equipment, and property from electrical hazards. Here are some key concepts to understand. Firstly, grounding establishes a low impedance path for fault currents to flow back to the power source, causing overcurrent protection devices, such as circuit breakers and fuses, to trip and de-energize the circuit. This prevents dangerous voltages from building up on metal surfaces, reducing the risk of electric shock. Secondly, bonding connects all metallic parts of an electrical system together, creating an electrically continuous path. This ensures that all metal surfaces are at the same potential, minimizing voltage differences and further reducing the risk of electric shock. Thirdly, grounding and bonding work together to provide a comprehensive safety system. Grounding provides a path for fault currents, while bonding ensures that all metal parts are at the same potential. Together, they create a safe environment for people and equipment. There are several types of grounding systems commonly used in electrical installations. 1. The grounded system is where one conductor of the power source, typically the neutral, is intentionally connected to the earth. This provides a stable reference point for the electrical system and helps to limit voltage fluctuations. 2. The ungrounded system is where no conductor of the power source is intentionally connected to the earth. While this type of system can offer some advantages in terms of fault tolerance, it is generally less safe than a grounded system because it does not provide a clear path for fault currents. 3. Equipment grounding provides a path for fault currents to flow back to the power source from the metal enclosures of electrical equipment. This is typically achieved by connecting the equipment enclosures to the grounding system using equipment grounding conductors. 4. Bonding jumpers are used to connect different metal parts of an electrical system together. These jumpers are typically made of copper or aluminum and are sized according to the requirements of the NEC. 5. Grounding electrodes are used to connect the grounding system to the earth. These electrodes can be ground rods, metal water pipes, or other approved methods. The NEC specifies the requirements for grounding electrodes, including their size, material, and installation depth. 6. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit and tripping the circuit if they detect a ground fault. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are based on the principles of electrical safety and are designed to minimize the risk of electric shock and fire. Some of the key NEC requirements for grounding and bonding include: firstly, the size of grounding and bonding conductors must be adequate to carry the maximum fault current that is likely to occur. Secondly, grounding and bonding connections must be made in a reliable manner using approved connectors and methods. Thirdly, grounding electrodes must be installed in accordance with the NEC requirements. Fourthly, GFCIs must be installed in locations where they are required by the NEC. Regular inspection and testing of grounding and bonding systems are essential to ensure their continued effectiveness. Grounding and bonding connections can corrode over time and conductors can become damaged or disconnected. Regular inspection can help identify and correct these problems before they lead to electrical hazards. Testing grounding and bonding systems involves measuring the impedance of the grounding path to ensure that it is low enough to effectively carry fault currents. There are various methods for testing grounding and bonding systems, including the fall of potential method and the clamp-on ground resistance meter method. Electrical safety is a critical concern in all electrical installations. Proper grounding and bonding are essential safety measures that protect people, equipment, and property from electrical hazards. By following the NEC requirements and using properly selected and installed grounding and bonding components, you can ensure that your electrical system is properly grounded and safe. Remember, a well-grounded and bonded electrical system is a safe electrical system. Grounding washers, also known as grounding star washers or external tooth-lock washers, play a vital role in creating secure and reliable electrical connections. Their primary function is to penetrate any coatings or oxidation on the surfaces being joined, ensuring a good electrical contact. This is particularly important in applications where the surfaces may be painted, powder-coated, or otherwise treated, as these coatings can act as insulators and prevent proper electrical conductivity. The design of a grounding washer typically involves a washer body with a series of sharp, pointed teeth or serrations extending outward from the inner or outer diameter. These teeth bite into the mating surfaces when the washer is tightened, creating multiple points of contact and breaking through any insulating layers. The resulting connection provides a low resistance path for electrical current, which is essential for grounding and bonding purposes. Grounding washers are commonly used in a variety of electrical applications, including firstly, grounding electrical enclosures, where they are used to bond metal enclosures to grounding conductors. Secondly, bonding metal raceways, where they are used to connect sections of metal conduit or cable trays. Thirdly, connecting electrical equipment, where they are used to ground equipment such as motors, transformers, and switchgear. Fourthly, automotive applications, where they are used to ground various components in vehicles. When selecting grounding washers, it is important to consider several factors. 1. Material. Grounding washers are typically made from steel, stainless steel, or brass. Steel washers are commonly used for general-purpose applications, while stainless steel washers offer better corrosion resistance. Brass washers provide excellent conductivity and are often used in marine environments. 2. Size. The size of the washer should be appropriate for the size of the bolt or screw being used. The washer should also be large enough to provide sufficient contact area for the electrical connection. 3. Type. There are several types of grounding washers available, including internal tooth lock washers, external tooth lock washers, and combination tooth lock washers. Internal tooth lock washers have teeth in the inner diameter, while external tooth lock washers have teeth in the outer diameter. Combination tooth lock washers have teeth on both the inner and outer diameters. 4. Plating. Grounding washers may be plated with zinc, cadmium, or other materials to improve their corrosion resistance. Zinc plating is a common and cost-effective option, while cadmium plating offers superior corrosion protection. The installation of grounding washers is a straightforward process. Firstly, clean the mating surfaces to remove any dirt, grease, or loose debris. Secondly, place the grounding washer between the two surfaces to be joined. Thirdly, tighten the bolt or screw to the recommended torque. As the fastener is tightened, the teeth of the washer will bite into the surfaces, creating a secure and reliable electrical connection. It is important to ensure that the grounding washers are properly installed and maintained to ensure their continued effectiveness. Regularly inspect the washers for corrosion or damage, and replace them if necessary. Also, ensure that the connections are tight and secure to prevent loosening due to vibration or thermal expansion and contraction. In addition to grounding washers, other types of grounding and bonding hardware are available, including grounding lugs, grounding clamps, and bonding jumpers. Grounding lugs are used to terminate grounding conductors to equipment or enclosures, while grounding clamps are used to connect grounding conductors to pipes or other metal structures. Bonding jumpers are used to connect different metal parts of an electrical system together, ensuring electrical continuity. Proper grounding and bonding are essential for electrical safety. By using grounding washers and other appropriate hardware, you can create safe and reliable electrical connections that protect people and equipment from electrical hazards. Always follow the NEC requirements and consult with a qualified electrician when designing and installing electrical systems. The NEC provides comprehensive guidelines for grounding and bonding, covering various aspects such as conductor sizing, electrode installation, and equipment grounding. Adhering to these guidelines is crucial for ensuring the safety and reliability of electrical systems. Additionally, it's important to consider the specific environmental conditions when selecting grounding hardware. In corrosive environments, such as coastal areas or industrial facilities, it's essential to use corrosion-resistant materials like stainless steel or brass. Regular maintenance and inspection of grounding systems are also crucial for ensuring their continued effectiveness. Over time, connections can corrode, conductors can become damaged, and grounding electrodes can deteriorate. Regular inspections can help identify and address these issues before they lead to electrical hazards. Testing grounding systems involves measuring the impedance of the grounding path to ensure that it is low enough to effectively carry fault currents. This can be done using various methods, such as the fall of potential method or the clamp-on ground resistance meter method. By regularly testing and maintaining grounding systems, you can ensure that they are functioning properly and providing the necessary protection against electrical hazards. In conclusion, grounding washers are essential components of electrical grounding and bonding systems, providing a reliable and low-resistance path for electrical current. Proper selection, installation, and maintenance of grounding washers are crucial for ensuring the safety and reliability of electrical systems. Always follow the NEC requirements and consult with a qualified electrician when working with electrical grounding systems.